Hey guys, welcome back. This will be an update on my Learjet flight simulator. Hey guys, welcome back. Glad you could join me today. For those of you new to the channel, my name's Eric. This is my Learjet flight simulator. For those of you who follow my channel, you've maybe seen some updates on this, and if you go way back, there's some really shaky build videos, but they cover the build of this from the ground up. I started in about 2007, and this is my flight sim. We have it, this is the first time I've fired it up in a while. It washes out on those main monitors, but we're just queued up on the ramp, sitting in Cuba, queued up for a flight to Miami. And I won't be recording the flight tonight. I'll try and do a full flight for you in the near future, but I thought I'd just give you a quick update and give you a little tour around the cockpit. In the console area, this is where it deviates from anything scale. What I have is the SciTech autopilot system, a space where I'm putting in a start panel. Actually, it'll go where the other SciTech panel is. Those are just used because the FGC isn't installed yet, although I do have one for it. So, also in the console, we have some monitors. Let's see if I can get a shot of those. So on this monitor, I have the Avlosoft electronic flight bag. It's an awesome program, guys. I really love it. It has a nice little kind of mini FGC for in-flight, and over here I finally have working my Rex weather avoidance system. This is what Real Environment Extreme, which injects and monitors my weather, allows me to see everything. I do have some other things on this console PC. This is a standalone PC. Actually, we can cover the PCs real quick in case you're interested. Up here on the main instrument panel, these two displays and these two displays are on a single Xeon server down there, and everything here is on another PC, and then FSX, Flight Simulator X, up here is running on an i7 quad core running at 4.9 gig. Heavy overclock on it, but it rocks out. It does pretty good. I just have the SciTech throttle quadrant with some 3D printed handles I made. Yeah, it's nothing scale. I don't have the real throttle quadrant, although I'm thinking about getting one. One more panel there, not interfaced. Lots of these panels still missing their caps. These panels still missing completely, but there's all kinds of build videos I made on this. This is my pressurization panel run with an Arduino. It works perfectly. Just love it. But yeah, that's pretty much it. Over here is the electrical panel. This is anti-ice lighting, the gear, and aux hydraulics and nose gear steering. All of this is fully interfaced. All these knobs, encoders, the MFDs, everything work. We can toggle through and look at the systems or the multifunction display. Up in the top, there's the EFIS panels. These are how you kind of control what we see on our primary flight displays, how you can switch between your nav modes. A lot of guys will be familiar with the EFIS panels who get into the flight sim. DU reversion, so we can revert the display units and swap them if we want to fly from the other side. That's pretty cool stuff. Works really, really well. Really happy with it, and we'll maybe go over to the primary flight displays and show you a couple things. So I'm not going to be able to show this real good, but this is our primary flight display with our altitude and our speed. Compass HSI, we can toggle that between modes, vertical speed indication, artificial horizon. And over here is the ICAS. This gives us all of the information about the plane, the engines, and anything important going on, any important messages we need to deal with. And we can toggle through and look at all the other systems on board as well. Works pretty good, pretty happy with it. And over next to it is the RMUs, the radio management units, and they are all fully interfaced, fully functional as well. That's how we control our radios, primary and secondary, as well as our nav radios, nav 1, nav 2. TCAS is also controlled from here, which shows up over here, so we can adjust the TCAS range, and it works pretty good. Pretty handy to see what you're about to crash into. Yeah, that's about it, guys. all of our kind of dummy lights and our backup gauges up here, and they're all fully functional as well. So next video, if you guys want, I'll maybe get this thing up for a small flight, show you from start to finish and start up. We'll fire up the engines, take it for a rip, and yeah, we'll do a quick hop. Really appreciate you guys watching. If you enjoy videos like this, please make sure that you hit the thumbs up button down below. Subscribe if you're not already a subscriber. Share this video. It really helps me, guys, when these videos get shared out. Really appreciate you guys watching, and good luck with all your projects. Old satellite downlink system, new satellite downlink system. This is the portable satellite dish system you saw me put together in previous videos for the EduCase project so that I could receive data and files anywhere in the world. I'm pretty excited to say we're moving up in the world. This was a KU band system, and we're now moving to an L band system, which is going to fit everything inside of this little case. So the previous satellite receiver was this. This is no longer usable at this time with the KU band because it's been shut down. So we've got to transition to this L band. What I'm getting is a 12 centimeter square patch antenna that'll fit inside this case, as well as it will run on a Raspberry Pi. So that will be our receiver going from this to this. Awesome weight savings, power savings, you name it. It's all going to be, it's going to be great. It's going to run off of a RTL SDR style dongle, an E4000 style chipset. I've used these in the past on the channel. You've seen them before. So it's going to be coming down at 1500 megahertz thereabouts, and we're going to pipe it through a 34 dB gain LNA, or a low noise amplifier, and then from there it'll go out to the SDR into the Raspberry Pi. The satellite we're receiving from is going to be the Inmarsat 4i3 satellite over North America for me here. That was launched back in 2008 from Kazakhstan. Pretty cool. They're broadcasting all kinds of content and now weather and other files as well. So really handy. Going to go well with the EduCase project. So in an upcoming video, I will put this together. I should have the antenna and all the other components arriving in 2 days or so. We'll get that put together and we'll get it hooked up to the EduCase. This Raspberry Pi sets up its own Wi-Fi hotspot with the Outernet Librarian interface so that my other Pi and all my other equipment in the EduCase can get the information wirelessly. Pretty cool stuff. Really happy with it. This is going to be great. We're shedding huge pounds. The batteries to run this are going to be self-contained in here, I think we'll do, and then we'll be able to stick the antenna out on the side of the case when we want to receive. Really happy. It's going to be light, durable, portable anywhere in the world, get the data we want and the data we need. So I will check back with you in a few days on this. Really excited, guys. Check out the other videos on the channel. I will see you soon. Cheers. Hey guys, welcome back. Last night I noticed that the Fox 1A Alpha Oscar 85 satellite was going to be making a pass, and I decided to try and go outside and grab it. What I do, if you haven't seen before on this channel, I take these cheap Chinese handy talkies and sometimes just walk outside and have a listen and see if I can catch one of these CubeSats or ham radio satellites going overhead. The Fox 1A is brand new. It's just put into the air not that long ago. It is identical in shape to this. It's a 1U CubeSat, and this is going to be the video I caught from it. If you're not a ham radio operator, you might find it a little bit boring, because what they do is they just make contacts really quickly off the satellite. It didn't work out the best because tuning for Doppler with rotating the radio with this antenna didn't work the best on that particular frequency. But hey, I caught it. It was a lot of fun. I love going outside and just catching a satellite going overhead with a under $40 radio. Can't go wrong. Good fun. Check it out, guys. Hope you like it.
Kilo Charlie Niner, Papa Indian Echo, Echo Mike. Kilo Charlie 9, Papa Indian Echo, Kilo 4. Go golf over. The Papa Yankee Mike. Yankee Sierra Echo. Kilo 8 Yankee Sierra Echo, was it? That is correct. Correct. Roger, Kilo 8 Yankee Sierra Echo, Victor Echo. Via QSL into Victor Echo, Papa Yankee Mike. Okay, Victor Echo 3, Papa Yankee Mike. Double 3. Alpha Echo Go. I'm at Echo Mirror 5, 5. Echo Mirror 5, 5. Over. NSA, DE4, November Sierra Alpha, Kilo 4. Echo Golf, Echo Mirror 5, 5. Roger that, Kilo 4 station, Echo Oscar 20. Victor Echo 4, November Sugar Alpha, KC9, ELU, Echo Mike 79. Victor Echo 4, November Sierra Alpha, KC9, ELU, Echo Mike 79. KC9, ELU, VE4, NSA, Echo Oscar 20. Roger, Roger, Victor Echo 4, November Sierra Alpha. Echo Mike 79, 7373. KN91, KYSB, EN91, KD8CAO, Echo November 62, dead. Okay, done.
Hey guys, welcome back. Gonna do a quick installment on the Arduino satellite project. So if you didn't see the previous videos, what I've done is I 3D printed a CubeSat. These are a 1U, exact 1-to-1 scale cube satellite. And if you're excited about space exploration and stuff like I am, print one of these off and just have it on your desk, because just having this sitting there it really inspires me and allowed me to take forward the project a little bit. So more or less, there's not much in here. You can see the previous videos. I have a charge control, solar control, and the battery. But what I did in the past is I took an Arduino, and what we did was RTTY downlink, and that didn't work. So we converted over to a CW, Morse code downlink, and that worked. It was awesome. It worked really good. So now we're taking it to the next level here, and we're going to try voice. Let's see if we can fire this up and you can hear what I've done. This is, you might recognize this as a recycle of the gas sensor grenade proto board. But hey, eventually we will do a proper PCB for in the satellite, but let's check it out. So we'll go ahead and hit reset, and you can hear what I've done.
Start. Mike, Kilo, Mike, Echo 1, ready. Power 5.
Okay, so that was actually the first steps on the moon, a really crude playback from the Arduino doing the voice, and it seemed to work pretty good. And let's hear what the telemetry is sending down via voice now.
Error, probe 1, pressure increasing 20, probe 2, current too low, probe 3, temperature 23 degrees, speed 1,000, 100, moving X2, Y, 0, Z, 0, break.
So that's the first cycle.
Kilo